Hi, this is Group 13 from Section 4 Chemistry. My name is Umesh, and also presenting with me today Sri Kuhan and Taranjit Singh. Our topic for today is going to be Boyle's Law. So, a quick introduction about Boyle's Law. Boyle's Law was founded in 1662 by Robert Boyle. It is also known as Marriott law, mainly in France, because the French physicist Edme Marriott also discovered the relationship between the pressure of gas and the volume of gas in 1676. Boyle's law can also be derived from the kinetic theory of gases.
Hi, my name is Rikuhan, matrix number AA200317. Today I'll be explaining about the key points for Boyle's law. Okay, before I explain the key points, let's look at a basic application for Boyle's law. Okay, Boyle's law is commonly used in air pumps, which is used to fill air in tires. Now, coming to the key points. The first key point, Boyle's law involves two main components, which is pressure and volume. Boyle's law plays its relationship between pressure and volume. Okay, gas volume is inversely proportional to pressure. The formula for Boyle's law is P1 V1 is equals to P2 V2. Now, what can we derive or say from this formula? Okay, when pressure increases, volume decreases. When pressure decreases, volume increases. That's why it is stated as gas volume is inversely proportional to pressure. When one component increase, another component will decrease. Okay, now what about the temperature? The temperature is always constant for Boyle's law. Okay, now Boyle's law can be derived from kinetic theory of gases. It's about the particles, the speed of the particles, the number of times the particle hits the wall. Okay, now looking at the graphs, we have two types of graph. The first relation, shows the inversely proportional relation for pressure against volume. That means when pressure increases, volume will decrease. That's why it is stated as inversely proportional. That's the first graph. Now coming to the second graph. The second graph shows directly proportional. Why directly proportional? Because pressure and 1 over volume. It's not pressure and volume, it's pressure and 1 over volume. When pressure and 1 over volume, it is directly proportional. That means when pressure increases, volume will increase. Why volume is increasing? Because it is 1 over volume. That's all from me. Thank you.
As my friend stated earlier, Boyle's law states that the volume of gas is inversely proportional to its pressure provided the temperature of the gas is kept constant. So to prove Boyle's law, we have chosen a product which is the bicycle pump. So why we choose bicycle pump is that because it is closely related to the Boyle's law. So here today I'm going to demonstrate how Boyle's law works on the bicycle pump. It's better than demonstrating the way how it works compared to we explain in the video, so it will be much more fun, interesting, and also it's easy to understand. So now I have a bicycle pump here. So now what I'm gonna do is I'm gonna pull this handle upwards. So as you can see, when I pull the handle upwards, what actually happens in the cylinder, because we can't see, so what actually happens to the cylinder is that the volume of the cylinder increases. When the volume of the cylinder increases, the pressure inside the cylinder decreases. This is due to Boyle's law, because volume of gas is inversely proportional to pressure. Hence, the pressure of the gas in this cylinder decreases. Now, I'm going to do the same thing but push the handle downwards. So as I push the handle downwards, what actually is happening in the cylinder is that the volume of the cylinder gets smaller. When the volume of the cylinder gets smaller, the pressure in the cylinder increases because of air molecules getting compressed. So when this causes the gas to be forced out of this nozzle as I push it downwards, and it releases, of course, some sound. So that's how Boyle's law works in the bicycle pump. So as earlier I proved how Boyle's law works, now I'm going to show how the bicycle pump works with the principle of Boyle's law by connecting it to a tire. So as you can see that I already set up the bicycle pump to the tire by connecting the nozzle to it. So now I'm going to show how it works. So we're going to watch carefully to the pressure meter here. So as you can see, the pressure meter here is about 0 psi. So now what I'm going to do is, now I'm going to lift the handle up, and now I'm going to push the handle down. So as you can see, when I push continuously, the pressure meter rises. This is because at the moment when I push the handle downwards, the volume of the cylinder decreases, hence causing the pressure to increase, causing the air pressure to flow out to the nozzle into a tire. So we can see the meter increases continuously as I continue this process. So that's how Boyle's law works.
Hi again. Now we are down to the conclusion of Boyle's law. Boyle's law is extremely important because it tells us the behavior of gases. It explains with certainty that pressure of gas and volume of gas are inversely proportional to one another. So if you push on gas, the volume becomes smaller but the pressure becomes higher. So Boyle's law is actually very important concept in engineering because it is very crucial when it comes to designing and using certain machines. So that is it from us. Hope you enjoyed our presentation. Thank you very much.